See here, I have 5 volts being used to power this Groove water automatization device, or module, and it's coming from my board over here, my level shifting board. I have it set up with the pins for the serial side. So this video is to take this little breakout board I created and turn it into a nice, effective PCB here so that I can get 5 volts or 3 volts out. Let's see if it works. PCB way for sponsoring the circuit board used in this video. I build the components for my level shifter here. You can see I have some of the resistors here and over there, the capacitors, the MOSFETs, and just some headers. So I'll be soldering it now. I've gone ahead and put on most of the components. I haven't done this other side yet. And I'm going to use a heat gun to get them in place. It's not the prettiest job. I don't have a stencil, so I've been using chips quick here and then just kind of dabbing it where possible. I'm hoping for the best. Now that I have it mostly soldered, I'm going to touch up the pins here for the I2C on both sides because I didn't really do a good job covering them with solder. And then I'm going to do the through-hole components. I did a decent job. And I will be moving ahead and testing it out next. After I do that, I will go on to using it for a project. I have my multimeter in the noise making mode if it has a connection, a direct one. And I'm just quickly testing attached to each of the wires to make sure that they are properly set up so I don't have any issues. So this should trigger on this middle pin, as expected. Next I'll check the ground. So I have ground now set up here, so it should be, I think, this one. Yep. Checking the expected place on the MOSFET, as expected. And that was for the yellow wire. I'll be checking the white wire last, which should be this one right here. I have the white wire plugged in. Let's give it a shot. As expected. Great, that side looks good. I'm going to check the other side next, and then I will go with it. The serial voltage now. Or the serial connections, and that is as expected. And next I will do the yellow wire, which should be the one next to it, as expected. I'll test the black wire next. Next I'll test the ground over here by touching the pin on the MCU, as expected. Next I'll be checking the voltage one. With it hooked up to the voltage, I'm going to test this middle pin here, which should trigger it. Get a better viewing angle. Yeah, so assuming my schematic is alright, everything should work. I have this symbol sketch set up with D4 through D7 set up to high as outputs, and this is just to test the level shifting aspects. I'll test it with an actual sensor once it's all set. And it's showing 3.3 as expected from the device itself. I'll be doing it next on the outputs from the Grove inputs, or Grove outputs. So I have the my multimeter set up, and it's currently pointing to the output here from the power line. It's getting about 3.27 volts, which is similar to what I was getting with it even without the logic in place here. So next I'll be testing the white wire, and like the red wire, I'm seeing 3.3 volts about there. As expected, I'm going to check the yellow wire next. And as expected, I'm seeing about 3.3 volts on the yellow wire. So next I will unplug this, just because I don't like messing with it while it's on, and switch the jumper to the 5 volts and give it another go. So I plugged it into the red wire here, and as expected it's showing 5 volts. The real test will be with the next 2 wires, the yellow and white, which I will be swapping out. Hooray! Showing 5 volts as expected on the yellow wire. So that's a great sign. I now need to check the white wire. And then I think we're good on the what side did I just test? The serial voltage side. And then I'll switch to the I2C side. Yay, we're seeing 5 volts there as well. So everything looks great. It's working wonderfully. Whew, big relief. Yes, so scary. I have these little wires sticking out here next to each other. But I'll switch to the opposite side and give it a go with the 3 volts and then again the 5 volts. And then we'll test with some project. Maybe I'll go back to the automatizer I like so much. We'll see. So with that set, I have it now plugged into the output of the I2C side, and I have it plugged into the red wire, the power, and it's showing a little under 3.3 as expected. So I will have to now test the other two, make sure they're 3.3 as well. So with the white wire plugged in, I am seeing 3.3. That's great. Yellow wire time. And I'm seeing 3.3 for the yellow wire. So we're set there. Now I just need to switch to the 5 volts and go through the same process. But it should work because it's using the same exact schematic as the other side. So it would be very unlikely for it not to work unless I really messed up the soldering, which is very possible. And we have it now plugged in with 5 volts on the jumper. And I'm seeing 5 volts, as expected on the red line. Yay. So next I'll be switching to the yellow and white. White is showing 5 volts, one last one to go, and then we're good with this to test with the sensor. Awesome, this is working as well. So 5 volts there. Yeah, so I was originally actually really worried about this, in part because I know that the level shifters that you usually see online don't mention that you can level shift to the same level. But I had tested in Falstaff, and I could see that it was still able to use the reverse bias nature of the MOSFET to leak or to trigger the pull to ground from the high voltage side. Otherwise, it wouldn't have worked. When I went too low with my testing, I think it was like 2.4 or so, it reached a point where it could no longer accurately pull down on the high volt side. But the low volt side was still accurately working. It was just it couldn't do it bidirectionally. But luckily, 3.3 doesn't have any issues, and these MOSFETs are great with it. Here I have this I2C display. I'm testing it first using Seed's expansion board, and then I'll be switching over to mine using 5 volts, which should still work. It accepts both 3 and 5 volts. So assuming there's nothing wrong, it won't break this display. Here I have it in the 5 volt configuration, and it's able to still handle I2C communication. Lovely! And I've already tested, as shown in the other videos, that it does in fact give 5 volts when it's put on that jumper. Thinking of what I could test, and I know the vision sensor from Seed Studio is the Vision AI V2 sensor, rather, is one that operates at 5 volts, not 3.3 volts. So what I'm going to do is upload a face detection model through the SenseCap SSCMA, SenseCraft rather, and from there I will take that and try it on first Xiao connected on the opposite side directly, and then I will unplug that and try via level shifting and I2C. So it should work in both cases, because what happens is if you plug it into the headers on the back of this, those ones back there, it gives the 5 volts from the VUSB pin. So in the case of this, it should be very similar, but we'll give it a shot. As expected, while I'm using the vision sensor directly connected, it's working. And now I'm going to try switching over to my level shifting board, and it should continue to work. It's set up to test it. It's using the I2C connection, which on the vision sensor here connects to a 3v3 linear regulator, voltage regulator rather. So it needs to have 5 volts for this, and hopefully when I plug it in, it will work. Well, continue to work rather. So yes, as expected, it is working. I have it here running, and I'm going to aim the thing at my face now. 1 second. And you can see I'm not doing a good job holding it steady, but when I am, you can see that it's able to get the bounding boxes. So I'm able to get 5 volts to it, and I don't have to do anything crazy like my original level shifter. And just to compare them, to get the 5 volts originally, I have this inline level shifter I had put together that takes 5 volts here on this side as the high voltage side, and the low voltage side got the voltage from the groove cable, with 3v3, and then outputted 5v5. So it's a great little inline level shifter, and I actually have another board I've designed that does the same thing for inline capabilities. But for this, I like that it can be just installed, and I can have 5 volts out the I2C line, which should work well. Thank you. I wanted to demonstrate using the serial communication from my device as that's the other side of it besides the I2C. And in this case, I have the 5 volt jumper selected, and I'm being powered actually via the Arduino Uno board here. And I have a buzzer attached on this side and a button attached on this side. And when the button is hit, it sends a message over software serial, well, hardware serial on the Xiao side and software serial on this side. see, it works as expected, allowing me to get access to additional pins on the Arduino board if needed. Just a cool way of getting it powered as well via that board if I needed this for some other side project. Anyhow, seems to work. Great. And with that, that's my level up board. Thank you for watching. This is my version 1.0, and I'll be making some modifications to add to the silk screen in the future, and I'll likely be using this for all of my projects going forward, at least the ones that require 5 volts and any sort of level shifting. Thank you for watching. Like and subscribe to the video for more content like this.